Our captain speaking, ground control has cleared us for takeoff. Skies look clear, but midway we do expect some turbulence. So buckle up, make sure your seat back and tray tables are in their upright and locked positions. And of course, we thank you for choosing to fly with us. So sit back and relax while you enjoy this informational video. Welcome aboard.
This is GE Profile.
So I want to thank everyone for joining me today in my talk titled IIoT Navigating Data Access Protocols, how OPC UA and MQTT prevent interoperability. My name is Matthew Parris. I work for GE Appliances. There I'm the senior manager for test systems within the factory. So my job is across the entire business is to ensure that the units that we're producing that are going to consumers' home are working functionally and that they're going to be happy when they get them into their house. We are headquartered in Louisville, Kentucky, which is about 5 hours south of here by car. We have 5 manufacturing facilities located there that were built in the 1950s. And we also have manufacturing facilities located in Tennessee, Alabama, Georgia, and also South Carolina. So my job is to cover all of these facilities. And so we took a journey about 2016 when we left GE corporate and we joined High Air. And High Air gave us a mandate to become the best appliance manufacturer in North America. And so we took that charge seriously and we started a journey with being very customer focused. How can we focus in on what the customer is, who the customer is, and what they want? And so as a result of that, we started this initiative to create a house of brands. So when you go to look for our products, you may not see GE Appliances, but you may see Monogram, you may see Cafe, GE, Hotpoint, High Air, or Profile. So these are all produced by the same technology teams, the same product management, the same supply chains, but they're all tailored to very different people within the market. So it is our job to be hyper-focused on the customer and deliver products that will serve their different needs. As you're able to see in the video, there's different people that want different performance, different types of what the requirements are out of their appliances. So it's our job to serve them. So this is a main principle of this entire presentation, is first you have to define your consumer. And then after you've defined your consumer, then you can begin to develop your producer. So for us in automation, many people have this upside down where they just put in a producer and then they expect it to be integrated, or they require teams to then just go bend over backwards to integrate it within the enterprise. But we're in Industry 4.0 now. That's not going to scale and it won't work. So you have to turn it upside down and you have to develop for your consumer. Think of them first. And so a little bit about me. I am an end user. I'm a manufacturer. I'm a little bit, I have a team that is very specialized. We deploy custom hardware, custom software solutions into our factory. And so we're a little bit of a system integrator as well. So we're very interested in technology. We're not a member of the OPC Foundation. We're not a member of the Sparkplug Working Group. We're not a member of OASIS. But we are very interested in choosing the right technologies that's going to enable our processes within our factories. So first things first, when we talk about industrial Internet of Things, it's a very, very big topic. And it can be very confusing and dizzying at times. So if you feel confused about what is out there, don't worry, it is very confusing. There's many pieces to this ecosystem: security, historical access, alarms and conditions. But for the purposes of today, we're going to be laser focused on real-time data access because I only have an hour, and I think I'm not even going to be able to cover everything I want to in that amount of time. I have some bad news that IIoT, that this is only the beginning, and products do not exist to do what we need to get done today. This is just where we're at the time. So if you feel frustrated because things have not settled out, just be patient because it will take some time to figure it out. That's the time we are in. If you recall, in the 1980s, early 90s, there was the protocol wars. Today we take for granted that we have Ethernet, TCP, IP. That was not the case. There were fights about how should we integrate these things on the plant floor? What physical interfaces should I be using? And it was not always clear what should be used. So we are in that case, except higher up the stack. So today, I can't recommend products. I can't tell you this is the solution. All I can do is impart to you 4 tools that will help keep you sane during this very chaotic period. So I want to take your understanding of what IIoT is, which is very confusing, disorganized, and turn it into something like this. So topic number 1, consumer-centric integration. I touched on this a little bit before, but we'll go into more detail what that would look like. Topic number 2, what is OPC UA and what is MQTT? Topic number 3, data access model. And number 4, a technology readiness framework. So to start, customer-centric integration. So as you recall, the OSI model has been published in the 1980s. And this was helping to sort out different technologies, different products, and to help organize the field. Okay, you're going to develop this thing, you're going to stay at level 1, level 2, level 3. You're going to develop this, so you're up at the application level. It's a way to help organize developers with integrators to understand the full stack. But then as time went on, it kind of collapsed and coalesced around what we think of as the internet model or the TCP/IP model. What you'll notice is that it standardized basically the data link as Ethernet. You have MAC addresses there. Standardized the network layer as IP, transport as TCP, UDP. And then they collapsed the application, presentation, sessions layers into just a single layer itself. So today we're going to build upon that and create an IIoT data access model. So right now we're starting very simply. We have infrastructure. So I'm saying let's assume we have reliable infrastructure in place. We have network switches, routers, Ethernet, all that. So let's ignore what all is involved in that, collapse it down to a single layer. And then on top of that we have application. And we're going to expand on that. So if you look in the top right, I have a legend, and this will kind of keep us together. So we're talking now of application and infrastructure. So let's talk about a single use case. You have a production application, you have infrastructure, and you have a device. This is about as basic as you can get. And this device can have any number of field bus protocols that it exposes. And so you have a requirement. Again, we're doing customer-centric integration. You have a requirement of that application to comply with that protocol to be able to consume the data from it. So you're doing point-to-point. It's not too bad. I'm just going to select an application that matches that field bus protocol. But now you have a second device. That second device may have a second field bus protocol. And now you leverage another requirement on your consumer that I must now support another protocol and a third. So if you haven't experienced this yourself when you're integrating a big system, as you increase the number of applications or as your application increases in scope, so does the time to integrate these things. So point-to-point integrations start to cost a lot more. So here we have more applications that we're adding, and we're trying to connect them to these devices. We're going to have to integrate all these point-to-point devices. And oh, by the way, let me add a fourth device, and who knows what that protocol may come. But I have to leverage or levy that requirement on every single one of my applications to satisfy that need. So again, remember the principle. First define your consumer, and then develop your producer. So as a consumer application, what would we rather have? We want to eliminate the cost of the integration for the consumer application. So let's go ahead and assume that we're going to have a diversity of protocols at the device level. There may be efforts to try to unify at the device level, but let's just for now assume that there's going to be diversity. So a good way to do it is just have a device gateway. So this device gateway, its job is to be able to talk all these different field bus protocols. And you're going to standardize communication from your machine level application. And it also helps the machine level application to have a single connection point. So now no matter how many devices you add to your system, your machine level application still has a single connection and it still has a standard communication interface. And oh, by the way, I've added a second application to the enterprise. It also has just a single interface to the gateway. And it also can leverage the same communication protocols used before. So now I can start machine level development of applications, and I can start to commonize that no matter what is below in terms of the device level protocols. And it also gives you the ability to offload the number of connections on the devices themselves, because many times the devices cannot handle many connections. So if you have thousands of applications, let's say, that are trying to get that device data, the devices themselves can't handle it, so this gateway helps offload that data. And if you still don't believe me about the diversity of protocols at the device level, I want to introduce you to a man, and this man was located on my university campus, and every time I walked by, he was always in this position, and he just always had something on his mind. Something that he's thinking about is Rockwell, one of the 4 founding members of the OPC Foundation, offers no PLCs with native OPC UA support. OPC UA, however, is available from Rockwell through a dual-core Intel CPU add-on module running Windows 10. Yeah, that's something to think about. So, point is, if Rockwell as a founding member is not implementing OPC UA as standardized as a device level, is just go ahead and give up and architect around that by using device gateways. So it's pretty simple when you have a machine level application and you have your device gateway. But again, consumer-centric integration. What if I have an enterprise level application somewhere in the enterprise, and I also want it to get access to the data? What does this look like? When we start thinking about it from the consumer's perspective, we want to connect the gateway to infrastructure, configure it to start providing data, and then the enterprise level application, without me touching its configuration, can just automatically start receiving its data. So that is a paradigm shift of what has usually been integration, where you add a device gateway, you have to go to the next level up, add its configuration to connect to it, go a level above it, make sure you keep subscribing up the chain. So what I'm proposing here is that you really need to consider, what does communication infrastructure look like? So you can see in the top right, our legend has gotten taller. So we added a layer between infrastructure, which is TCP/IP Ethernet, and the application. So we're now saying that there is a communication layer that's separating, and this is to help integration with the consuming applications. So what do we mean? What does it look like for the communication layer? So if you recall in the past, if I wanted to integrate before the OSI model was really presented, I really had a physical layer, and that was it, just wire. A lot of controls are still wired this way with dry contacts, for example. So as a consumer, I had to know exactly where the location of that device was in the plant. So to help the consumer application, we added a layer on top of that, which is the data link layer. And so now we have a device called a network switch, where I don't care where the producer is physically, as long as I can connect into the switch, then I'm okay. And so I've made life easier for the data consumer. I've eliminated his need to have to know the physical location of the producer. So to even make it easier for the consumer, we add another layer on top of that network layer. So I can stop caring about the physical switch that I need to connect to, and as long as I know the IP address of the producer, then this infrastructure is able to take care of the rest of it for me. But we're now in a time where even knowing IP addresses of a thing is not enough because it doesn't scale. And that's where a communications layer comes into play. So we're going to have something like a router, like a switch, in its place so that the consumer doesn't even need to know the IP address of the producer. It just needs to know a path to the data. And so what that would be is just generically an aggregation application. So you can have this application sitting between the device gateway. It provides a single connection point to the enterprise level application. And that way, when you add a device gateway to the network, for example, it's able to connect, provide its data, and now the application level, enterprise level application is automatically able to get the data. You could even get more advanced if you scale this out to your enterprise. And depending on what you want to have in the cloud, what you want to have on premises, what the impact is if a node goes down, how much of your facility is taken out. That's all under consideration when you architect a system like this. So this is what we mean by consumer-centric integration. How can I make it as easy as possible for consuming applications to integrate? So when I add in equipment within a line, I have less work to do up above with all the applications that are going to get built. So topic number 2, what is OPC UA and MQTT? So looking at OPC UA, client server specifically, if I have a data producer to try to automate that integration process, I got to have a discovery server where it's going to register its presence to, and depending on my configuration of the firewalls, the data consumer will then be able to use reverse connect and subscribe to the data producer. And then the consumer at that point is able to send publish requests however often it wants the data, and it gets the responses with the changed data. And that just sits there in that loop doing the publish requests and getting the responses. But if we're looking at a communications infrastructure, I want to add an aggregation application in the middle. So looking at client server, I would be able to have the data consumer connect to the aggregation application. This aggregation application is going to do federation. So it's going to be able to pull in all the data and make it available to everything that's connecting to it. Then also I have this discovery server so that the producer, when I bring it online for the very first time, it says who it is, it registers, aggregation application automatically connects to it, starts pulling in its address space. And then the data consumer, again, it has no idea where the data producer is in the network. It doesn't even know the IP address of the data producer, but it's able to subscribe to the data of the producer through this aggregation application. So it's basically acting as a data router of sorts. And of course, we want to add some redundancy to it, so if we have a fault in the aggregation application, the whole system does not come in. So if we look at the infrastructure, communication, application layers, what does this look like? So we have communication happening with client-server functions down at the communication layer. But at the application layer, that's where we're requiring to have redundancy, reverse connect, federation capabilities, and discovery servers. And the best that I can tell, there have not been products developed yet that have all of these functions included since the OPC UA spec was released in 2006. I'm aware of MajorCon Data Broker, I'm aware of Softing SIS, but they have some of these features like federation. They don't have redundancy. Some MajorCon has reverse connect, but they haven't integrated discovery services to help automate that piece of it. But the good news is that there is a technology that has been available since 2009 where those functions, federation, reverse connect, discovery server, are at the communication level. They're inherent to that communication protocol. And then it's just the redundancy piece that is a requirement of the application, and that is known as pub sub functions or MQTT broker. So if you've ever see articles when they're saying MQTT versus OPC UA, typically they're trying to communicate something like this of, are we going to do a client-server architecture, or are we going to do pub sub MQTT architecture? So if you look at OPC UA client-server aggregation, really you have custom definition. There's no standardized definition of what is an OPC UA aggregation server. It is a specialized application. It's only going to be typically used within an industrial setting, and it is closed source, so it's only produced by the company that is elected to take that task on and then create a marketable product out of it. If you look at MQTT pub sub broker, it's pretty much well defined as what that product is. There's multiple vendors that provide it. It is used outside of manufacturing, so there's many IoT applications as well that help create different use cases that help harden the capability of the product so that you're not the only ones in the market using the product, and other bugs get found for you. And there are open source and also enterprise options as well. So what is this MQTT stuff, pub sub? How does it work? So you have the same thing. You have an aggregation application in the middle, but in this case it's an MQTT broker. And you have the producer and the consumer both connect to it, just like before. And so the consumer says, I am interested in a certain topic. Let's say I'm interested in plant/cell and everything underneath that. And the producer, it starts to publish that topic. And every time it publishes it, the aggregation application, the broker in this case, just passes it on to the data consumer. So again, the data consumer didn't have to do anything. It just said, I'm interested in this data. If the data is available, I will get it. And that process happens over indefinitely as the data producer has data. And if the producer says, I'm going to publish data to a different topic, that data does not go through to the data consumer because the consumer doesn't care about it. Okay, topic number 3, data access model. So we've talked about what could look like at this communications layer where this new device, this new application is a broker. But that's not enough. We're Industry 4.0, we got to scale up. We got to help automate integration. We need interoperability. And that requires a new layer, an informational layer. So we need something to where I no longer care about what is the IP address of the node that's producing the data. I don't care about what is the path of that data. All I need to know is just give me the name of the object. And you could structure your informational model to say I have 5 plants. I know I can connect to this plant. I can search for a node within that. So we need information on top of the communication layer. So just to expand on this model, so we have the TCP model where it collapses the application space into one layer. Everything we're talking about in IIoT is actually within that application layer. So we have to split it out. So we split it out into communication, information, and the actual application, which is what you actually want to do with the data, why you're doing this whole thing to begin with. But actually, this model is not enough to help understand what is out on the market. You need something more explicit. So at the communication level, you have 2 layers that I propose. You have a communication protocol itself, but then on top of that, you have a definition of how to use that protocol. Because it's not enough to say we're going to use MQTT, we're going to use TCP, we're going to use UDP. You also have to standardize, and I'm talking about interoperability, you have to standardize how you're going to use that protocol. Then regarding the information, there's certain levels to that as well. So you're going to have data coming across the wire, and it's going to be encoded in a certain way. You have to be able to understand that encoding. So if you have interoperability, you have a producer that has data encoded a certain way. That means that your consumer has to also understand how to decode that data. Then on top of the encoding, you have variables. So do we have data types defined, and what is allowed to be used? What names are we going to use? Standardize on that. And then above that is the holy grail, and that is, can I define an object that actually organizes all the variables in a very meaningful way where I don't have to customize that piece of the integration. So what does this look like in real life? So just to use an example of something we're all familiar with is web browsing. So if we have a web browser, of course the transport is Ethernet, TCP, IP, for example. The communication protocol is HTTP or HTTPS today. And then there's mappings, there's browser functions, there's GET, POST, etc. And then on top of that, you standardize an ASCII text. That's actually how the information is encoded back and forth. And then the ASCII text is representing the hypertext markup language, and that's how the browser can decode the different variable types, and then that's all organized within an HTML document object model. So that is all happening behind the scenes, but that is why browsers are able to go to different websites and understand what is being presented with it. It's very standardized, and it's a simple stack there. Another example, a RESTful API. So you have HTTP as a protocol, then you have API methods as they're defined with the interface. But it's not so standardized because the encoding can be any number of things. You can have XML, JSON, YAML, any number of things. It's all determined by the API, whatever they choose. But at least they're common in that a resource. So if you know I'm going to call this API, I have to refer to this resource, I know I'm going to be able to get data. But the objects in an API is all custom. There's no definition, there's no standardization about what an API object should be, so it's left custom. So if you've ever integrated with an API, you know you have to read the documentation about what that API is, what does this variable mean, and how do I use it. That's all custom integration happening at the object level. So if we look at applying MQTT and OPC UA within this framework, MQTT, and we're talking about MQTT versus OPC UA. If we look at MQTT, we standardize on Ethernet, TCP, IP at the transport layer. We standardize MQTT at the communication level, but how we use that protocol is undefined, is custom. What topic paths should I use? What topics should I publish when? Should I publish on change or should I publish at a defined rate? All that is undefined. What encoding should I use? Am I sending a bitmap image? Am I sending text, strings, integers? And then what variables do I use? What do I call them? What do I name them? And then what objects do those represent? That entire stack is fully custom. So if you say, I'm going to standardize my equipment on MQTT, be aware, you have a lot of integration to do ahead of you. You've got to study each of those layers and then create the consumer application to be able to handle it. So let's look at OPC UA. They've standardized on each of these layers. So they have options of Ethernet, IP, or TCP at the transport layer, for example. Communication layer, they've standardized on TCP or HTTPS or WebSockets. And then they have standard mappings of client-server interactions. They have encodings of binary or XML or JSON. And then the variables, there's over 60 base data types that you can make use of. So if you think about the world of Modbus, where I have 4 data types, OPC UA is way more rich in that regard. But in 2006, it's all custom objects. So you can make any object you want as you piece together these base data types. But in 2018, OPC UA over time has expanded to include various companion specifications. That's the name they give to these object models that are at the layer 5 at the top there. They also included other transport mechanisms that they refer to as pub/sub. So they added MQTT as a transport, AMQP, UDP, and Ethernet mappings as well. So when you think about MQTT and OPC UA, they're both opposite sides of the same coin, is really what it is. Because with MQTT, you have custom integration of the stack, but you say, I want to integrate with OPC UA on all of my devices. Well, you still have to determine at every one of these layers, what does that actually mean? So you still have custom, if all you say is OPC UA, you still have custom integration to do up the stack. Is it doing client server? Is it doing pub/sub? Which encoding is it doing? And that is what the market is trying to figure out now.